Welcome everyone to Shop Talk, an informative video series brought to you by Kimray and Kathairos Solutions. I'm Kelsey, brand lead at Kathairos Solutions, and I'll be today's moderator. In the fall of 2024, Kimray and Kathairos formed a partnership combining Kimray's longstanding leadership in energy control systems with Kathairos' new innovative emissions elimination technology to deliver scalable zero-emission solutions to upstream oil and gas facilities. Join us in this series as we explore comprehensive strategies and tailored solutions that address the evolving needs of the industry, ensuring you can meet emissions goals efficiently without compromising on reliability and performance. Whether you're assessing your site, updating equipment, or overhauling your pneumatic systems, Shop Talk is here to guide you every step of the way toward a cleaner, more sustainable future. I'm excited to welcome you today for our first episode called Sizing for Zero Emissions Pneumatics. We're diving into essential criteria and questions producers are asking, whether they're at the beginning or well on their journey towards zero emissions. Today, joining us is Kyle Andrews, Sales Enablement Manager at Kimray. Kyle leads his team in developing and managing comprehensive online training materials and curriculum for his sales team. He and his team oversee ongoing sales training and onboarding for new personnel, ensuring they have the knowledge and tools to succeed. Kyle collaborates closely with the marketing team to create engaging product content for Kimray's industry-leading YouTube channel and website. With 14 years of experience at Kimray, he has expertise in upstream oil and gas production and passion for educating others about Kimray's products and the industry. As well, we have Mitch Jones, Technical Account Manager at Kathairos Solutions. Mitch has been with Kathairos Solutions for over 2.5 years, progressing from an applications engineer to a role on the project management team, supporting asset deployments from scoping to installation, commissioning, and transition to operations. He now serves as a Technical Account Manager, helping customers plan for zero-event pneumatics. Holding a degree in energy engineering from the University of Calgary, he expertly assists clients in evaluating sites to estimate pneumatic vent rates and eliminate methane emissions. So to kick off our first episode and today's theme of sizing for zero emission pneumatics, I'm going to get right into it and turn to you, Kyle, on our first question. So when an operator is looking at converting a site to zero emissions process controls and pumps, what are the top 3 things they should start with for that transition process?
Yeah. First of all, Kelsey, thanks for having me on. I'm excited to be here. But when a producer is looking at changing, their sites over to zero emissions, basically, that's a huge project. But I come from it from a controls standpoint. So when I hear that question, I automatically go to like products they need to convert. So for Kimray specifically, that's going to be our pneumatic regulators. That's going to be on any of our high pressure control valves, and then the pilots that control them, whether that's level controls, or if you're controlling pressure, or even if you're controlling temperature. And kind of the first step in changing those over for a customer is knowing what direction you're going, right? Are you going to non-vent? Are you going to an outside source? Are you going electric? That's kind of the first question they have to answer to really start going towards that conversion. So that's always where I try to lead people off is, hey, let's figure out how we want to get to zero emissions, because there's a few different paths to go. So let's make sure that we decide on one and then start that journey down that path.
Great.
And Kyle,
Mitch?
when operators come to you, Kyle, just a question on, do they normally come with questions about what you recommend they do, like outside supply, non-vent, or other solutions, or is that they come with this is what we want to do?
So I would say most of the time this is what we want to do, like help us get there. A lot of the times though, they'll just come to us with an end goal in mind. Like, hey, this is where we want to be, in the next year. How can we most efficiently get to that end goal? And so then that's when we start exploring those different options. But a lot of the time they have a preconceived idea of how they want to do it. And then they're coming to us for us to apply the correct product to what they want to do.
Right. No, that's good info. And yeah, I guess from our perspective, when we're working with producers to plan out their zero event conversions, kind of like the main first step that we typically talk with them about is just gathering, that pneumatic inventory database. Some companies have very in-depth data with, all their sites, which devices are operating at each site, which wells are associated, which equipment is associated to each device. And then others have no data at all, whether it's like really old legacy equipment or, they recently purchased assets. So that's typically one of the first things we would ask for is like, okay, you want to convert this list of sites, kind of what is out there? Like, what do you guys have for pneumatic controllers? And do you have an understanding of how long they've been there, what the service life has been on them? And then also, one of the big things that affects it is just, production rates and what they expect for the future of that pad, like any future development. Is it going to be, is equipment going to be added or taken away? So that's kind of one of the main things we work with producers on, is trying to understand their inventories and also work with them to assess them.
Great. Thanks, Mitch and Kyle, for those insightful answers. Let's move on to the next question here. So let's discuss the main factors that influence vent rates at oil and gas sites. So Mitch, I'll get you to start on that one. Based off the experience of Kimray and Kathairos, what are the largest drivers of vent rate at a site?
Yeah, from Kathairos' perspective, the primary and largest driver of vent rate at site is typically leaks or malfunctioning devices. Lots of the legacy Quad C type facilities or even Quad B have had pneumatic controllers operating for a while. Since they've been using gas to date, fuel gas or even instrument air in some cases, there hasn't been a need to go around and make sure everything's functioning properly and all the system is buttoned up. So we typically see when we install a system that the operator thinks their pneumatic control system is optimized, but they're really wasting a lot of fuel gas or methane or venting directly to atmosphere. So that'd be kind of the first one. The second one is any legacy high bleed devices that may have been missed in the conversion process, or pneumatic pumps that typically use a lot of gas or they're injecting chemicals, or doing various different things, transfer pumps. Those are also very high consumers. And then the last thing that we really look for and help operators evaluate is liquid production rates, because that, new facilities or new pads that are producing a lot of liquids typically correlates to a lot of, actuation cycles for level controllers, for instance. So that's where, we would help them evaluate of what do you expect for actuation cycles, because that does use a lot of gas. And then we kind of see that vent rate taper off as the facilities, their production rate kind of declines.
Yeah, I would echo a lot of that same stuff. I mean, for Kimray control specifically, wet or dirty gas is kind of the biggest cause of both malfunction and just continuous venting. Under normal operations, all of our pneumatics are categorized as intermittent vent. But if you introduce wet or dirty gas, even compressed air can be, have some moisture in it, which could cause issues. But that's going to be one of the biggest causes of venting on a site. And then something else Mitch mentioned is just actuation rates. I mean, you're going to wear out valve packing faster. And so it's critical to understand your controls and have a good idea of what needs to be repaired or fixed, once you go to whatever solution, whether that's, nitrogen, whether that's compressed air. You don't want to be wasteful. So you want to fix all of those leaks and unnecessary venting before you apply that solution. So that way you're efficient when you're running that solution.
Yeah, and I'll just add that's one of the big benefits for us working with Kimray is we've gathered all this, nitrogen usage data in our case, which directly correlates to what would have been vented previously. So we have a pretty good understanding of when a customer is producing this much liquid or they have these types of devices installed, this is what we would expect based on our data set kind of across, thousands of devices across North America, what they should be venting. And then obviously, as Kyle mentioned, like all the devices for Kimray's side are classified as intermittent vents. So if they have devices and we're seeing continuous high usage, there's obviously a problem. So it's, that's one of the benefits working with Kimray is trying to understand how the devices and controllers operate just to help the customer optimize their system.
Yeah. And Mitch, when you got a customer coming to you and you've got that historical data, are you looking at it by region? So like similar wells to what, let's say we've got a customer in the Permian who's looking at different solutions. They call you and say, hey, I've got a 2-well pad. Do you have a pretty good idea of what a 2-well pad in the Permian should require from a volume standpoint?
Yeah, we do. We do have a pretty good database now kind of broken out regionally, assuming that for the most part, all the facilities in a region are designed somewhat the same. Maybe the legacy sites are slightly different than, newer facilities, but that is how we would do it. If we have a customer in Pennsylvania, for instance, once we start operating on one of their facilities or, we're on a neighboring pad with similar design, we can pretty effectively estimate what it's going to be if they just tell us, it's a 5-well pad with 5 GPUs or, this many devices. And then even just, giving like a ballpark production rate, we can pretty accurately estimate what we think the vent rate should be, assuming everything's functioning properly.
Okay. It's really easy whenever I'm sure people are converting from a compressed air solution to Kathairos because you're just matching the volume output of that compressor, right? They should know how much that they're consuming. So I'm sure that conversion is pretty simple.
Yeah. If they do have measurement, it definitely helps. One of the things we do run into quite a bit is when, if customers are switching from instrument air to nitrogen, given that they are using air, like back to the leak discussion, they could be leaking tons of air, but they don't necessarily care. So, they send us a number, we're using X scuffs a minute. And would kind of right away we'll raise it of like, okay, I know that's what the meter says, but like how much of that is just being, leaked through connections or, bad seals on devices or whatnot. So
yeah. And from the Kimray side of things, I mean, we can give you the volume of each size actuator, and we have a calculator that calculates from our standpoint a vent rate, but you can use that backwards to understand how much volume you'll need. But again, that's under ideal conditions. Everything's perfect. There's no leaks anywhere. So that's a good starting point, I would say.
Great. Thanks to you both for that deep dive into the vent rates. Now let's shift our focus a little bit. I'm going to throw this question to you, Kyle. How does the zero emissions process control and pump solution factor into sizing? And can you explain the difference between electrification, instrument air, and nitrogen?
Yeah, so from a sizing standpoint, from like just the valve itself, it won't really affect the sizing at all. I mean, it's important to understand the actuation rate and how much volume of nitrogen or compressed air or even supply gas you'll need. So I wouldn't say it affects it greatly from that standpoint. As I mentioned before, when a customer is making a decision to move towards zero emissions, there's a few different paths. So you mentioned electric, non-electric, pneumatic, and what was the third one? Remind me.
Electrification, instrument air, and nitrogen.
Okay, instrument air and nitrogen. So those are all ways to get to zero emissions. Electrification is really more on the valve side of things. So electric actuators on each valve, electric controls. So like instead of your pilots being pneumatic, they switch to electric with your controlling liquid level, pressure, temperature, or flow. And I would say that the main difference between, I'll kind of put the pneumatic side on one end and then the electric on the other end, would be if you're more automation heavy, some customers like going the electric route because there can be more automation going that way that you can use. On the pneumatic side, there's benefits too because you don't have to change out your existing equipment. There's a huge learning curve, and I think over the last probably 10 years, our industry has gone through this where there's new technologies coming out, but then you have the people who've been in the industry such a long time that the learning curve on automation and all these electric products is pretty steep. And so the good thing about you still sticking with pneumatics, whether that's nitrogen or compressed air, is you get to keep all the same equipment. Everybody's familiar with it. You're not changing any of that, so nobody has to learn anything new, but you're still getting away from emissions. So I would say those are kind of the biggest divider or differentiator between electric and then the pneumatic side. And then between the compressed air and nitrogen, there's a lot of different factors in deciding that, but I would say with nitrogen, you're getting a clean, dry source that's repeatable, and there's really no failure points. When you use compressed air, you've got to worry about the compressor, maintenance, downtime. Even if the downtime efficiency seems high, like 99% or 98%, if that's just one location though. So if you add all these hundreds of locations you might have together, you might be down 30% of the time at any given site. But with nitrogen, as long as there's nitrogen there to be used, it's going to work. It's going to be there. You don't have to worry about power going out or a supply of natural gas to the compressor, or if it's an electric compressor, you don't have to worry about those things going out.
Yeah, I would just echo like one of the main differentiators that our customers typically come to us for is, sites without access to power. If it is doing the electric actuation option, whether they have a power supply on site or relying on, solar systems, which depending, where you are in North America may or may not work all year round. And then same with compressed air, you need access to the power grid or on-site generation, or again, larger solar packages. And that's kind of the main benefit with the Kathairos system is that we don't need any. It's a completely standalone system with no external power. Well, one other question I had, Kyle, is like when some of the feedback we've got from operators when they do go the electric actuation route is it kind of limits the ability of their operators to work on the systems. Once those are installed, they need to rely on, I&E teams. Is that, do you guys find that a lot too?
Yeah, definitely. That goes back to the steep learning curve, right? So a lot of that can't be done in-house anymore. It has to be contracted out. Some larger companies have their own I&E teams, and so it's a little bit easier for them. But for a smaller producer or somebody who doesn't have an I&E team in place, that is a big roadblock into getting into electric actuation. Is if you don't have somebody who knows what they're doing and knows those systems, you're kind of dead in the water without some help.
Mm-hmm.
Great. Thanks both for that explanation. Building on that point, Mitch, and I know we touched on this a little bit in the last answer, but what are some challenges that you've seen working with operators on sizing for zero emission pneumatics?
Yeah, I'd say the primary challenge we find working with producers is just the limited data they have on their pneumatic device inventories and how much they're emitting. Especially it's quite surprising some of the companies, even if they purchase new assets, maybe the previous company had no data at all of how many devices they have, how many sites they have. So that's kind of the first hurdle of, they come to us for sizing a system, but it's tough to do that without an understanding of, where is this site, how many devices are at this site. So that's probably the main one, working with them to make sure the device inventories are updated, keeping track of all the conversions they've done, or if they've previously converted, Kimray devices to non-vent systems. All that stuff is good to have. And then kind of back to the leak discussion, it's just, the limited maintenance that's been done on the pneumatic system was when they're relying on fuel gas. So, they think they're emitting something based on emission factors, but when you factor in all the leaks, maybe it's 3 times, 5 times that. You don't realize that until you have a limited supply of nitrogen on site where we can measure how much is actually being used, that we can understand that fully.
Yeah. And I think Mitch touched on it earlier, but knowing your actuation rate too, and if volumes are going to be changing, whether that's decreasing over time or bringing on new production and them increasing. And so it's important to know where you're going. But also, like from a valve standpoint, if you've got a valve that's actuating a lot, it might be an indication that it's not sized correctly. So, making sure your valves and the trim in those valves are sized correctly for the production you have is critical. But again, getting accurate data up front is going to be super helpful. And Mitch, here's a question for you that I've had. Let's say a customer applies the Kathairos solution to their location, and it ends up being, not enough volume or too much volume. Like how easy is it to swap out the different size tanks to kind of correct as you apply the solution and you figure out your volume needs?
Yeah, great question. And it is very simple from our side to swap out tanks. So typically what we recommend, if customers don't have good pneumatic device inventories or estimates of their vent rates, we'll just suggest, let's just put a tank on there for, a 30-day trial, and we can just measure the usage. And then if it is significantly higher or lower than we thought, the tanks are completely, you don't need like any prep work to the pad, really. They just set directly on the ground. They all come on pallets. So it's just a matter of, hooking up the one tank to one 1/2-inch connection and then delivering the larger, smaller tank and just setting it in place. It's on a pallet, sits directly on the ground. So it is a really simple process from our perspective. So that is one of the benefits we find working with, as we're onboarding new customers, especially, is we'll put a tank on, if we need to adjust the size, we can quickly do that. And then, now we have the data and we can kind of apply that to, a vast majority of their sites once we have an understanding of how much this site is producing, kind of what the design is, how many devices they have, what all the controllers are doing.
Yeah. And what's your suggestion on, as a customer is, converting over to nitrogen? We mentioned leaks before just within the system, whether that's, through, old O-rings and soft goods on the actuator side. Like, what is you guys' suggestion on repairing or doing maintenance before the nitrogen is supplied to that system?
Yeah, so we always recommend to our customers to, before they switch over to nitrogen or are still on fuel gas or the existing system, to do like very thorough pressure leak checks on their system, whether that's using, camera technology to understand if they are buttoned up. And then if they're not, relying on companies like Kimray that has field service teams that can go out or perform that service as well, like doing the leak detection and they're repairing any, old devices where the seals are no good, for instance, on plunger actuators or, various different devices. So that's kind of the main thing of, hey, can you guys make sure you do a thorough leak check? And that's one of the services we've added to recently, is having a camera with our commissioning team. So as we go around, we can flag these things. And if there does need to be repairs, we can, suggest Kimray to the customers to have to have those devices or the seals kind of tightened up or replaced as needed.
Great. Thanks, Mitch and Kyle, for highlighting those challenges. And as we continue in this conversation, I'm going to turn to you, Kyle, again. Can you recommend any resources or tools that operators could use to evaluate the sizing of a tank and powering their pneumatic system?
Yeah, I would encourage you guys to just visit Kimray.com. We've got a lot of good tools on there. One I mentioned before is the vent rate calculator, and we can put a link to that here, but it's just going to ask you a few basic questions. So the size of the actuator, the size of the supply tubing and the length of that tubing, and then the actuations per hour. And that's a good starting point. It also asks for the supply pressure. We use 30 PSI as a standard for all of our products, but just put your supply pressure in there, and that will give you a scuffs per hour or per day that you need for that one device. So you would do that for each individual device, or just multiply that by how many regulators you have or control valves. And that'll give you a good idea of where you need to start. But as Mitch mentioned, there's flexibility on tank size and finding the correct size tank.
And I'll just add, for us, now that we have all this data, as I mentioned, we kind of have developed emission factors for various regions based on device counts, production rates, legacy of the wells. So the company really has no idea where to start estimating their emissions, whether it's using the Kimray calculator or, even relying on Kathairos to help estimate the emissions. We have a full team that kind of uses this data, compares it to your site design, where you're operating, and can help estimate what we think what you're currently venting and kind of what we estimate the usage would be.
Great. Excellent insights from both of you today, and really appreciate your time. That wraps up all of our questions for today. Thank you both for sharing your insights and helping us understand more about sizing for zero emissions pneumatics. And thank you everyone for listening to our first episode of Shop Talk. Again, a special thank you to Kyle and Mitch for joining us today. We hope today's insights have enabled you with the tools and knowledge necessary, no matter where you are in transitioning towards zero emission pneumatics. Stay tuned for more episodes as together we continue exploring innovative solutions and strategies to meet your operational and environmental goals. Kimray and Kathairos are committed to helping you through your zero emissions journey. You can get in touch with us directly by visiting Kimray.com and visiting the emissions solutions page, or going to their live chat, or Kathairos.com and selecting get started. If you have any additional questions, please leave a comment below. And if you enjoyed this episode, please like, comment, and share with your network. Till next time, thanks again.